Welcome back, students. This is our second lecture of AVE. Third unit we were studying, that is HDTV. In this third unit, in the first lecture, we have seen introduction to the HDTV, different resolution systems related to the HDTV, different signals related to the HDTV. Today, we will see the concept of HDTV transmission, how the HDTV transmission is done, and how the reception of the signal is done in the HDTV particularly. Okay, let's start the HDTV transmission or HDTV transmitter. In HDTV, both the video and the audio signal that must be digitized by A to D converters, and they are then transmitted serially to the receiver. Because of the very high frequency of video signal, special techniques that must be used to transmit the video signal over a standard 6 MHz bandwidth TV channels. Means initially we have to digitize, or we have to convert by using analog to digital converter audio signal as well as video signal, and after that we have to use different special techniques for the transmission of video signal over the 6 megahertz bandwidth TV channel. Next to that, we can say that, and because both video and audio that must be transmitted over the same channel, the multiplexing technique that we have to use here, that must be used here. The FCC requirement is that all this information that can be transmitted reliably over the standard 6 megahertz television channels, now defined by the NTSC TV, assume that the video to be transmitted that contains the frequency up to 4.2 megahertz. It means that for the purpose of transmission of the audio and video, both the signals, we are using multiplexing technique, so that both the signals that can be transmitted over the same channel or same bandwidth, we are using 6 megahertz channel for the purpose of transmitting video and audio signal. So we are considering here the video that is to be transmitted that contains the frequency that is up to 4.2 megahertz. For this particular signal to be digitized, it must be sampled at least 2 times per cycle, or at a minimum sampling rate of 8.4 megahertz. If each sample that is translated to an 8-bit word or a byte, that particular byte, 1 byte, and the bytes that are transmitted serially, then the data stream has a rate of 67.2 megahertz. Means for the purpose of digitizing that particular signal, we have to sample twice the rate of original rate, means 4.2 megahertz rate. We have to increase the rate twice. We can sample that particular signal at 8.4 megahertz. That's why the data stream that is having the rate of 67.2 megahertz. So multiplying this by 3 to get 67.2 is equal to 201.6 megahertz. So add to these the audio channels, and the total requirement bandwidth is almost 300 megahertz. So to permit this quality of the data to be transmitted over the 6 megahertz channel, especially encoding and modulation techniques we are using here for that purpose. Okay, getting the idea about the transmission of HDTV. Now let's see the exactly block diagram of the HDTV transmitter. This figure shows the block diagram of the HDTV transmitter, which consists of camera at the starting of that particular transmitter, then ACC MPEG to data compression technique we are using here, then data scrambler, Red Solomon error detection we are using here. After that we are using encoder, packetizer, after that multiplexer, frame formatter also we are using, and D to A converter we are using. Different components or different blocks we are using for the purpose of transmitting that particular high definition signal over the definition transmitter. Now let us see in detail. This particular figure shows the block diagram of HDTV transmitter. The video from the camera, whatever the video that we are recording from the camera, that consists of R, G and B signals. Okay, we have seen it in the before lectures, how that particular R, G and B signals are formed. They are converted to the luminance and chrominance signal. We have seen this also, how these RGB signals are converted to the luminance and chrominance signals. These are digitized by A to D converters. Okay, here we are digitizing, we are using ADC circuit after the camera. Whatever the signals we are having that at the camera, that are digitized by using A to D converter, and the luminance sampling rate that is equal to 14.3 megahertz, and the chrominance sampling rate is 7.15 megahertz. Get in mind these two sampling rates: 14.3 sampling rate for the luminance sampling signal, and for the chroma signal, the sampling rate is 7.15 megahertz. Okay, after the digitizing that particular signal, that is converting analog signal into digital, we are passing it through a compressor. We are using MPEG2 compressor here for the purpose of compressing that data. The resulting that signal, that is serialized and then sent to the data compressor. The purpose of this device is to reduce the number of bits that are needed to represent the video data, and therefore it permits the higher transmission rate in a limited bandwidth channel. Okay, getting it? What is the need of that particular data compressor? That is to reduce the number of bits that are needed to present the video data. Okay, reducing the number of bits for the purpose of presenting that video data, and so permitting higher transmission rates in a limited bandwidth, means we are using a limited bandwidth and we are giving a higher transmission. MPEG2 is the data compression method that we are using here in the this particular HDTV television. Okay, this MPEG2 data compressor that processes the data according to an algorithm that effectively reduces and redundancy is in this particular video signal. Means simply here we are reducing the redundancy in that particular signal. For example, we can say that if the picture is one half light blue sky, okay, half light blue sky, the pixel values that will be same for many lines. Okay, for the half line, for the full line, for number of lines, the pixels for that particular will be similar. That is the data how we are compressing the data, reducing the redundancy. Redundancy is nothing but the same pattern when there is occurring, we are reducing that same pattern, that is reducing redundancy. All this data that can be reduced to one pixel value, that is transmitted for a known number of times. Okay, that data that is reduced one pixel value transmitted for the known number of times. The algorithm that also uses fewer bits to encode the color than to encode the brightness, because of the human eye is much more sensitive to the brightness than to the colors. Okay, the MPEG2 encoder, that particular MPEG2 encoder that captures and compares the successive frames of video and compares them to detect the redundancy, so that only differences between the successive frames they are transmitted. The signal is next sent to the data randomizer. Okay, data randomizer, we are sending that signal. The randomizer scrambles or randomizes the signal. Means scrambling or randomizing is done in that particular for the signal is done that in that particular block. That is done to ensure that random data that is transmitted even when no video is present, or when the video is a constant value for many scan lines. This permits the clock recovery at the receiver. Okay, what is the need of that particular thing is that ensuring the random data that is being transmitted when no video is present, or when the video that is having the constant values. Okay, this particular thing permits or allows us for the clock recovery at the receiver side. Next, the random serial signal that is passed through a reed Solomon error detection RS error detection block and error detection and correction circuit. This circuit particularly adds extra beats to the data stream, so that the transmission errors that can be detected at the receiver and corrected also. This particular thing ensures that high reliability in signal transmission even under severe noise conditions also. Means by adding that particular extra bit, the whatever the noise or whatever the what we can say, and whatever the extra, by adding that extra errors that are have been detected in that particular receiver, that can be detected here by using this particular reed Solomon error detection and correction circuit. Next, in HDTV, the reed Solomon correction and detection circuit, that encoder adds 20 parity bytes per block of the data that can provide the correction correction for up to 10 bytes error per block. The signal that is next fed to a trails encoder. This circuit further modifies the data to permit the error correction at the receiver. Trailing encoding is widely used in the modems also. Okay, whatever this particular trail is encoding, whatever the data that was at the output of the Breed Solomon error correction and detection, that was passed through the trailees encoder block. This particular trailees coding is not used in the cable television versions of HDTVs. The audio portion of the HDTV signal, that is also the digital signal. Okay, it provides for compact disc, that is CD quality audio signals. The audio system that can accommodate up to 6 audio signals or audio channels. They can permit monophonic sound, stereo and multi-channel surround sounds also. The channel arrangement here is flexible to permit the different systems. For example, we can say that one channel that could be used for a second language transmission or closed captioning, each audio channel that is sampled at 48 kbps rate, ensuring that audio signals up to about 24 kilohertz are accurately captured and then they are transmitted. This is how the particular it is flexible to permit the different systems in that particular channel arrangement system. Here, each audio sample that is converted to the 18-bit digital word, the audio information that is time multiplexed and then transmitted as a serial bit stream at a frequency of A data compression technique that is designed for AC3, which will be used to speed up the audio transmission. Okay, after this daily encoder, the video and audio data that we are having, that data or data streams, that is packetized, that is passed through the packetizer, that is they are then converted to the short blocks of data bytes that segments the video and audio signals. Okay, these packets and then multiplexed along with some synchronizing signal for the purpose of formation of the signal to be transmitted. The result is that 188 bit pixel, that packet that is containing both video and audio data plus 4 bytes of synchronization bytes and the header. Okay, what we have seen now, the packetizer, they are multiplexed along with some synchronization signal, means whatever the data stream for the audio and video we are having, that particular signal and a synchronization signal, these three things are multiplexed at the same time to form the signal to be transmitted. Whatever the actual signal that we have to transmit, so for the purpose of forming that particular signal, we are using the multiplexing here. The result of that is 188-bit packet that is containing both video and audio data plus 4 byte of synchronization bytes. What we have multiplexed before, one is video containing video data, audio data, that is data streams, plus the synchronization bytes, that is 4 bytes we are using for the purpose of synchronization. All these things will be present at a 188-bit packet that is to be used for the purpose of transmission. Here, the particular header that identifies the number of packets and its sequences as well as the video formats. The next packets, they are assembled into frames of data that is representing one frame of video. The complete frame that consists of 626 packets, they are transmitted sequentially. The final signal that is sent to the modulator. In short, we can say that whatever the header file we are having, that header file is having different number of packets that we are using for the purpose of transmission, and next we are having the sequences of all the packets. Okay, next all the packets, they are assembled in that particular sequence, and then the particular complete frame that consists of 626 packets that we are transmitting in a sequential manner, so that the final signal that is transmitted, that is sent to the modulator for the purpose of modulation over that particular block. Here, the modulation scheme we are using in the HDTV is 8 VSB. VSB is vestigial sideband. This vestigial sideband modulation technique we are using here for the HDTV transmission. Okay, or 8-level vestigial sideband it is called as the amplitude modulation. It is a type of amplitude modulation. The carrier that is suppressed here and only upper sideband is transmitted. Means particular carrier is suppressed upper sideband of the that particular modulating signal is transmitted plus a small vestige signal, a small portion of lower sideband, we can call it as the small portion of lower sideband, that we call simply as a vestige of a signal, means vestige part of a signal that is added to that particular uh, upper sideband, and this both in the combination is transmitted after the modulation. This is nothing but a vestigial sideband modulation. That is a type of amplitude modulation we are using here. After that, the serial data that is sent to a D to A converter, where each sequential 3-bit group that is converted to a discrete voltage level. This particular system encodes the 3 bits per symbol, thereby greatly increasing the data rate within the channel. For example, we can say that each 3-bit group is that is converted to a relative level. For this, it is signal that is amplitude modulates the carrier. Whatever the signal we are having, we are using amplitude modulation here. We are suppressing the carrier. We are using one upper sideband or lower sideband, any one sideband of the particular modulating signal, and vestige signal of the another sideband, and in that particular we are transmitting that particular signal, resulting into symbol. The resulting symbolic rate here is 10,800 symbols per second. This particular symbol rate that translates to a data rate of eliminating the extra rs and trailing bit, that gives an actual video audio rate of about 19.3 mbps. So, a modified version of this format that is used when the HDTV signal that is to be transmitted over a cable system. Here, trellis coding system we are using that eliminates a 16 VSB modulation that is used to encode the 4 bits per symbol. That thing gives us the double data rate of terrestrial HDTV transmission, that is 38.6 Mbps. The VSB signal that can be created with a balanced modulator to eliminate the carrier and to generate the sidebands. Once particular sideband is removed by a filter or by using phasing system, the modulated signal that is up converted by a mixer to the final transmission frequency, which is one of the standard television in the HF, that is very high frequency or ultra high frequency range. Linear power that amplifiers is used to boost the signal level prior to the transmission by the antenna. It means that whatever the signal we have done D to A conversion at this particular transmission, that signal by using the balance modulator and the SB filter, we are up converting that particular signal, and after that by passing it through a power amplifier, increasing its power, we are transmitting that particular signal over the antenna for the purpose of transmission. Here at the multiplexer we have used video signal as well as audio signal. Means we in video signal A to D conversion we are doing, same we are doing in our audio signal also. After that data compression technique we are using. For the purpose of video we are using MPEG to data compression. For the purpose of audio we are using AC3 data compression technique. After that it is multiplexed and packetized. This particular audio signal is formed into the packetized format, and then it is passed through the passed to the multiplexer, where audio signal, video signal and the synchronization signal, both these signals are multiplexed, and after that they are transmitted over that particular transmitter. This is how the HDTV transmitter works. This is the detailed working of a HDTV transmitter, how the different, it passes through a different blocks and whatever the different processes are done in this particular transmission. Okay, getting the concept of HDTV transmitter, how this particular transmission is done in high definition television. Now let's move towards the next point, that is HDTV receivers. How this particular HDTV receivers work. An HDTV receiver that picks up the composite signal, whatever the signal that was transmitted over an antenna. That particular composite signal is picked by the receiver, and then it demodulation is done and decodes the signal into original video and audio formats. That is in the combination format. Composite signal is nothing but the combination of audio and video that is decoded into audio and videos information signal. A simplified receiver block diagram we will see now. This is the simplified receiver block diagram. The receiver of HDTV that consists of antenna, receiving antenna, tuner, amplifier, then demodulator circuit is also used here, equalizer circuits, different decompression techniques. In the transmitter we have used a compression technique. Here we are decompressing the signal so that we are getting exactly equal signal that was transmitted. Okay, demultiplexing also we are using because we have multiplex there. By demultiplexing we are differentiating or decoding the two signals, audio and video signals. We are getting the two different signals in two different formats, audio format and video format. This is a simplified block diagram of a HDTV receiver. Now let us see in detail what are the blocks present in this particular HDTV receiver and what is the working of each and every block present in that HDTV receiver. The first block present here is first thing present here is the antenna. This is a receiving antenna by which we are receiving whatever the information that was transmitted by using the transmitter antenna in the transmitter block diagram. Okay, now here after the antenna will receive that particular signal, it will go to the tuner circuit. The tuner and IF system here, IF amplifier system, they are similar to those in the standard television receivers. In the standard analog television receivers we have seen the tuner circuit and amplifier circuits. It is exactly similar to that here in the HDTV. From there the 8 VSB signal that is demodulated by using a synchronous detector into the original bit stream. In the VSB we have modulated the signal. Here we are demodulating that particular signal so that we will get exactly the signal that was transmitted there. Okay, by demodulating we are getting the original bit stream signal. A balance modulator we are using after that. For that for the balance modulator, the purpose of using balance modulator is that it is used along with the carrier signal that is phase locked to the pilot carrier to ensure that accurate demodulation is being done here or not. The balanced modulator we are using for that purpose. A clock recovery circuit that regenerates the clock signal that times all the times that remaining digital operations. Here the purpose of clock recovery circuit is for the purpose of generating the clock signals. Okay, the signals they are then passed through the NTSC filter. Here we can see a NTSC filter. It is passed through that particular NTSC filter which is designed for the purpose of filtering out any one channel or adjacent channels. They are interference from standard television stations. Okay, that is the use of this particular block here. The signal is then passed through an equalizer circuit. Here we can see the equalizer circuit after the NTSC circuit. Okay, the equalizer circuit here, this particular equalizer circuit we are using for the purpose of adjustment in the signal to the correct amplitude and phase variations encountered during the transmission. Means while transmitting we are making different adjustments into the signal in the phase and the amplitude. To make the different corrections in that we are using this equalizer circuit. The signals they are at the output of equalizer are then demultiplexed into video and audio bit stream. This is a very important block here. What is the purpose of this particular demultiplexer? The purpose of demultiplexer is used to demultiplex video and audio signal. We are having composite signal. That composite signal consists of audio signal, video signal and synchronization bits. Okay, here what we can see, the work of demultiplexer is to demultiplex this signal, to decode this signal or to convert this signal into the different formats, video signal, audio signal and different synchronization pulses. Sorry. Okay, it means that whenever we are using multiplexer in the transmitter we are using demultiplexer here. Okay, we are using modulator in the transmitter, we are using demodulator here. Just like that we are using RS decoder, trellis decoder and RS decoder here, because we have used their RS encoder and trellis encoder in the transmitter block. The trellis decoder and RS decoder here in the receiver block ensures that the any received error that are caused by the noise they are corrected. Okay, they are they are captured by that particular decoder and then they are corrected by using the correction circuit. Okay, noise or the extra elements they are added in the channel. The signal is then, after they are passing through the decoder, whatever the signal at the output of this decoder is descrampled and decompressed. next to that it is descrambled and decomposed. The video signal that is then converted back to the digital signal that will drive D to A converter. Okay, that in turn drives the red, green and blue electron guns into the CRT. Means whatever the signal, digital signal we were having, we are using D to A converter, and we are converting that particular signal into the colors, into the analog format, that is red, green and blue color format, that will be bombarded over the CRT present over the receiver side of the particular television block. The audio signal here that is also demultiplex and fed to the AC decoder. Okay, the resulting digital signal that are fed to D to A converter, means decoder decodes that particular audio signal that is passed through D to A converter for the purpose of gaining the audio signal, that converters for the purpose of creating the analog audio for each of the 6 audio channels. In this way, whatever the signal that was transmitted at transmitter side, by passing it through the different blocks, by converting that particular signal into different formats at the transmitter side, after the transmit it is passed through the transmission antenna, it will be received, or it will be picked up at the receiving antenna, and it will be passed exactly at the opposite blocks that are present at transmitter. And by passing that through different blocks in this particular receiver, we can form exactly equal signal that was transmitted initially. Means whatever the signal that was transmitted, same signal we can form at the receiver side. Though we have made different changes in the transmitter side, we are making exactly opposite changes in the receiver side, so that if we are use modulation technique at the transmission, we are using demodulation here, we are using different techniques, encoding, decoding. By that, whatever the signal that was transmitted, the same signal we have received at the receiver side. Here in this we have seen one concept, that is scrambling and conditional access system. What is scrambling? It is to suppress the synchronization signals at transmitting end. The picture without H and V synchronization that cannot lock into steady pictures seen as a rolling pictures and diamond bars. For descrambling, a pilot carrier containing the synchronous timing information is then transmitted on separate carrier. Another method with great security and complexity is baseband scrambling. For the purpose of scrambling, the scrambled coded lines are then decoded, and it is requires demodulation process. Scrambling here is possible by digital processing of video and audio, and introducing complex encryption and smart keyboards for controlling access. Nowadays, whatever the addressable converters they are used, that includes tunable converters and address recognitions also. Whatever the address recognition circuitry also, that is introduced by a computer to a specific channels, they are turn off and on to the subscriber. For that purpose, we are using the addressable converter, so that that particular user can turn off and on that different channels over the television set. Now let's see the next concept we have seen here, conditional access. What is the conditional access? The equipment compatibility access is a conditional access that supports user system interface, telephone communication module also. Okay, the technique that is used as scramblers and injectors, they are upstream, and these scramblers we are using here modules. In cable and satellite television system, we are using 3 different operationals are projected here for the conditional access. The access to a given channel for fixed duration, pay per view with the pre-selected choice of channels, pay per view with without pre-selection, means we have not selected before and we are paying for the per view of that particular, just like video on demand, movie on demand, music on demand we can see nowadays. Just like that, this 3 conditional access, these 3 different operations, they are projected here by using the conditional access term here in the case of HDTV transmission. Okay, means different conditions they are applying for the purpose of accessing different channels. Okay, means we can access different channel for the fixed duration, we can pay for that particular duration only. Next we can have a pre-selected choice for the channels, and we can pay per view for that pre-selected choice of the channels. And next we have seen we are paying for the different channels that we have not pre-selected before. Okay, that also can be done. These three things we can do in the conditional access. Different, by considering different conditions, we can access the different channels in this particular HGTV access.